This is your video for section 4.3. In this one, we're going to talk about the graphs of the tangent and cotangent functions. Let's start with the tangent function. For this one, we can fill in some different function values. And remember for this that tangent of x is the same as sine of x over cosine of x. That was one of our quotient identities from the first chapter. When we're filling out these values for tangent of x, any place that cosine is equal to 0, then tangent is undefined. That would be at negative pi over 2 and at positive pi over 2. Then where sine of x is equal to 0, that means tangent of x is 0. And then at negative pi over 4 and pi over 4, sine and cosine have the same values, although one may be negative and one positive. At negative pi over 4, we get negative 1 for the tangent, and at positive pi over 4, we get positive 1. Now let's look at what the graph of this looks like. You can see where the tangent is undefined. At those two places, we get vertical asymptotes. So these are important locations when we're doing the graph. This is where we have a vertical asymptote, and this is where we have a vertical asymptote. This point right in the middle between these two asymptotes is where the graph crosses the x-axis. So this point right in the middle is an x-intercept. And then we have these 2 points, and those ones just have easy y values to figure out because they're either negative 1 or positive 1. When we're doing the graph of this, we're going to call this point halfway between the two asymptotes, we're going to call this the midpoint. And these two, since they're 1/4 of the way through and 3/4 of the way through, we're going to call this the quarter point and the 3/4 point. Now let's look at what's happening to our graph of tangent. As x goes from negative pi over 2 to 0, our function values increase from negative infinity down here up to 0. And then as x goes from 0 to pi over 2, our function values just keep increasing from 0 up to positive infinity. That means that tangent of x is always increasing. If we look at the domain, what we have to do is leave out the x values where those asymptotes are. We're just going to put in here what x can't be equal to, and that is any odd multiple of pi over 2. We could write this as 2n plus 1 times pi over 2. So x can equal anything except for those values. The range, if we look at this going from bottom to top, we're going all the way from negative infinity up to positive infinity, and that gives us our range. Where we have those vertical asymptotes, we say the graph is discontinuous. This would be anything that's an odd multiple of pi over 2. This is also where the vertical asymptotes are. Looking at this, or looking at the way we wrote the domain, that tells us the locations of our vertical asymptotes. Our x-intercepts are going to happen at any multiples of pi. We could say those are of the form n pi, where n's an integer. What happens with this graph, we've only got one panel of it graphed, but after this it just starts repeating the same pattern. We would have the same thing over here, and if we went this way we'd have the same pattern again. So that means the period is going from negative pi over 2 to pi over 2, which is a distance of only pi units. That means that for tangent the period is pi instead of the first 4 functions we talked about that had periods of 2 pi. And then last of all, if we look at just the part we have graphed here, this is symmetric across the origin because we have one point here that's pi over 4 positive 1 and a point over here that's negative pi over 4 negative 1. So these are reflections across the origin. And that means that this is an odd function. That also tells us that if we put in the opposite value of x, we also get the opposite y value. So we have these matching pairs of points that go across the origin. Now let's look at the graph of the cotangent function. Remember, this is the reciprocal of the tangent function, but we can also think of this as being cosine over sine. That means that any place that sine is equal to 0, our function is undefined. That would be at 0 or at pi. any place that cosine is equal to 0, then we would get a function value of 0. So this would be halfway between these 2 points. And then we've got similar values as what we had with tangent at pi over 4 and 3 pi over 4. At pi over 4, both sine and cosine are positive, and they both the square root of 2 over 2. That makes this value a 1. 3 pi over 4 is in the second quadrant. That means that cosine is negative. For that y value, we get a negative 1. We're going to do the same thing with the graph here that we did with tangent. So we have our two vertical asymptotes. This is a vertical asymptote right here at x equals 0. And then we have one at pi. Our midpoint between those two is actually an x-intercept. So that would be this point right here. And then we have quarter point at pi over 4 and a 3/4 point at 3 pi over 4. So this is the 1/4 point and this is the 3/4 point. Now one big difference between cotangent and tangent is that cotangent decreases everywhere. If we look at this as we go from 0 to pi over 2 on the x-axis, this is decreasing from infinity down to 0. And then if we continue from pi over 2 to pi, it decreases from 0 down to negative infinity. Where tangent was always increasing, cotangent is always decreasing. For the domain, we want to leave out any place that there's a vertical asymptote. Those would be all the multiples of pi. We're just going to say x is not equal to n pi, where n is an integer. For the range, if we go from bottom to top, we're going all the way from negative infinity to positive infinity. Our graph is discontinuous at these values. That's also where our vertical asymptotes are. The x-intercepts are going to be halfway between our vertical asymptotes. That's going to give us any odd multiple of pi over 2. If we compare this to what we had for tangent, these two things are just switched. For tangent, our domain, we were leaving out the odd multiples of pi over 2, and the x-intercepts were at multiples of pi. This one is exactly switched. For this one also, we have one full period between 0 and pi. After this, we would start repeating the same pattern. That gives us a period of pi. And this function, it's hard to see what it's symmetric to unless you draw another panel over here. But for this function, if we look at a point here, we're going to have a matching point over here across the origin. That means this is symmetric with respect to the origin. That makes it an odd function, and that means that cotangent of negative x is equal to negative cotangent of x. Now we're going to look at some graphing techniques for these two functions. These are a little bit different than the first four functions we talked about. For one thing, the period is different, and for another thing, we don't have the 5 key points that we talked about with sine and cosine. We've got the two asymptotes, and we've got the midpoint in between those, and the quarter point and the 3/4 point. So we're still looking at 5 key x values, but they stand for something a little bit different. And the first big difference is that the period of our basic function is pi. If we're doing some kind of a transformation, then the period is going to be pi divided by b. Instead of with those other functions, it was always 2 pi divided by b. That's the first thing we're going to want to find is the period. And then we're going to find our 5 key x values, which is going to be the locations of our two adjacent vertical asymptotes, the midpoint between them, and then the quarter point and the 3/4 point. And here's what they are for tangent and for cotangent. They're different for the two functions. For tangent, our vertical asymptotes are negative pi over 2 and pi over 2. Those are going to be the endpoints of our interval where we have one full period. The midpoint between those two for the basic tangent graph is going to be 0, 0. That's going to be an x-intercept. We'll have a quarter point at negative pi over 4, negative 1, a 3/4 point at pi over 4, 1. For this first step, we're just looking at these x values. So we've got these two at the ends of the interval. We've got this one in the middle, this one at the quarter point, and this one at the 3/4 point. We're going to do just like we did with the sine and cosine functions. We're going to list these x values in order and then see how they change. So for example, if we had a tangent graph, we would list these 5 x values in order. We'd have negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. For cotangent, again, these are a little bit different. The ones on the ends are 0 and pi. Our midpoint is at pi over 2. Our quarter point is at pi over 4, and our 3/4 point is at 3 pi over 4. What we would do to find the new x values would be to apply any period changes. So we would take each of these and divide by the b, just like we did with our period, and then we would apply any phase shifts to these. That's going to give us the x values for these 5 things. From that, we can go ahead and sketch the vertical asymptotes. We can mark the locations of the other 3 points on the x-axis. After that, we want to apply any vertical transformations, so any vertical stretches or shrinks, reflections across the x-axis, or vertical shifts. These are just going to affect the y values of our 3 points, so our midpoint and our quarter point and our 3/4 point. So these things affect only the y values. Our x values are going to be whatever we figured out in step 1. Then once we figure out the y values for those 3 points, then we can plot those points, and then we're just going to join our points with a curve. Where we have our vertical asymptotes, we want our curve to get close to the vertical asymptotes on each side.